Good morning, AOBI. This is Mr. Dunning. Stand by. I have a math lesson for you. Today's talk is going to be about the equations of ellipses. We're going to learn how they're written. And then we're going to work with those to graph ellipses. We're going to learn how to find the ends of the major axis, the ends of the minor axis, and the two focal points, or foci. Those are the critical parts in an ellipse, and they're quick and easy to graph. We're going to do a handful of examples, well, maybe 6, I don't know, 5 or 6 examples, and after that, you should be good to do this. Okay. First off, graphing ellipses. This is a lot easier than you might guess, but we can't graph one until we have an equation of one. So let's do that now. The basic equation of an ellipse, x minus h quantity squared over a squared, plus y minus k quantity squared over b squared equals 1. Let's do an example. In this example, the center of the ellipse is at x equals 2, y equals 1. This works just like a circle. The HK is the XY coordinate of the center of the ellipse. Now, 9 is a squared, so a has to be 3. 4 is b squared, so b has to be 2. Let's try another one and see if you get it. What do you think? In this ellipse, the center is at -1, 2. A squared is 16, so a is 4. B squared is 9, so b is 3. That's how the equation of an ellipse looks and how it works. Now, let's run with those into the next topic, graphing ellipses. Ready? In this ellipse, the center is at 2, 1. 2 over, 1 up. I know that a is 3 because a squared is 9. So I'm going to go over 3 this way. That's the end of a going that way. 3 this way. And that's the end of a going that way. B is 2. So from this point, I'm going to go up 2 and down 2. These are the end points of A. These are the end points of B. And that's all I need to sketch this ellipse. And there you have it. Now, on the major axis, there are 2 points called focuses, or foci. And you know that they are located, well, let's remember, The foci are at plus or minus the square root of a squared minus b squared. 9 minus 4 is 5. So in this example, the foci plus or minus the square root of 5 from here. That's the center of the ellipse. Square root of 5 is a number, bigger than 2, smaller than 3, but closer to 2. So I'm going to put one here and one here. Those 2 points right there are the foci, or focus points of the ellipse, the centers, as it were. This is the center of the ellipse, but the foci are how you would connect the string and draw the ellipse. Piece of cake. Let's do the next one. In this ellipse, the center is at minus 1, 2. Minus 1, 2. A is 4 because a squared is 16. So I'm going to go 4 this way to the right end of A. 1, 2, 3, 4. And put a dot. And 4 this way to get to the left end. 1, 2, 3, 4. And put a dot. Those are the ends of my major axis, the end points. The minor axis, B squared is 9, so B is 3, so I'm going to go up 3. 1, 2, 3. Now I have the ends of A, my major axis, and the ends of B, my minor axis. Quick sketch. And there's my ellipse. Now on the major axis, we have the foci. And if you remember, they're that far from the center. A squared is 16, B squared is 9, 16 minus 9 is 7. So the foci in this ellipse are the square root of 7 that way and that way from the center. Now once again, the square root of 7 is just a number, that's it. Strange way of writing a number, but that's how you do it. It's a number bigger than 2 and smaller than 3 and a little bit closer to 3. So we'll go 1, 2, 3. 1, 2, 3. And those would be the foci of this ellipse. Sketching an ellipse is not hard because you've got a squared, that gives you A, b squared, that gives you b. When you know A, you know how far to go that way to the edge of the ellipse and that way to the edge of the ellipse. When you know B, you know how far up and how far down to go to the top and bottom. Once you've got the end points and the top and bottom points, you can do your sketch. The foci here are the a squared minus b squared under a radical. But you've got a squared and b squared in the equation, so that computation is easy. Graphing an ellipse. The ends of the major axis, the ends of the minor axis and the foci. Easy. Notes on ellipticity. Remember when we talked about this, we drew A and B. And the next stop to see this was to draw the tangent to the ellipse. And then, to allow this piece here to swing up, now this piece, this green piece, is still A. This red piece here this red piece here is the square root of a squared minus b squared. Projected down here, this point is a focus. And obviously there's another one over here too. That's why the foci are the square root of a squared minus b squared from the center. Now let's talk about ellipticity. I need for you to put your thinking cap on here. If we allow B to grow till it's almost up here, like that, we've got almost a circle. And when we allow that to happen, A swung up there, and that makes a squared minus b squared very small. This piece, very small. And when we compare that to A, we have a very small number over a big number. Now, I think that you can see that when we get all the way up, we have a circle, and there's a zero ellipticity, so ellipticity has to live in a number bigger than zero. Because if we let B go all the way to the top, we don't have an ellipse. There's no ellipticity, it's a circle. But let's look at the other possibility here. What happens if we let B get very, very small? Like down here, very small. Well, our tangent line here and our connection to it are going to give us an a squared minus b squared that is huge, almost the same size as A. So if we let this B get down to zero, we don't have any ellipse, we have a straight line. I think you can see that the ellipticity has to live between 0 and 1. At 0, we don't have an ellipse, we have a circle. And at 1, we don't have an ellipse, we have a straight line. B has gotten all the way down to nothing. So, notes on ellipticity. It has to live between 0 and 1. And our connection to it are going to give us an a squared minus b squared that is huge, almost the same size as a. So if we let this b get down to 0, we don't have an ellipse, we have a straight line. I think you can see that the ellipticity has to live between 0 and 1. At 0, we don't have an ellipse, we have a circle. And at 1, we don't have an ellipse, we have a straight line. B has gotten all the way down to nothing. So, notes on ellipticity. It has to live between 0 and 1. Let's review what we said today. We started off looking at the equation of an ellipse. The general form, x minus h quantity squared over a squared, and y minus k quantity squared over b squared equals 1. Then we did a couple of examples to show you how incredibly easy it is to graph these things. You find the center, and then you use a squared to find out how big a is, and that tells you how far to the right and how far to the left of the center you need to go to the end points of the ellipse. Then you use b squared to find b, to find out how far up and how far down you have to go to the top and the bottom. Once you've got the top, bottom, left, and right end points, you can sketch the ellipse. Then we looked at the foci. And remember, the foci are the square root of a squared minus b squared away from the center. Then we looked at ellipticity. That was our last stop. And we said that if b goes all the way to the top, we don't have an ellipse at all, we have a circle. There's no ellipticity, 0. So the ellipticity has to be bigger than 0. And if we let b get very, very small, then a squared minus b squared is going to be very, very big, almost the same size as a. In fact, if b gets down to 0, we don't have an ellipse either, we have a straight line. So the ellipticity has to live between 0, a circle, and 1, a straight line. I told you you'd have a little bit of fun with ellipses. And you might wonder, where do we find them? Well, planetary orbits, okay? The orbit of the moon around the Earth. Ellipses describe orbits of heavenly bodies. Once again, I want to tell you all, you've been a fantastic audience. Now tomorrow, you have your quiz, and it's going to cover everything that we did Monday, Tuesday, and today. Circles and ellipses. So be ready. There's going to be 10 problems, 12 problems, like last week, all coming out of the lessons. Have a great Wednesday night. We'll see you tomorrow.